Okay, so just before we close the class yesterday, so we started a OSI layers, open system interconnect. Open system interconnect, it is a networking model. It is a reference model, means no organization is uses OSI model. But why should we learn OSI model for understanding of network to maintain and troubleshoot the network related issues? Open system interconnect is useful. Okay. So it is any type of networking model you are using, either it is a TCP IP model or a Apple Talk, SPX, IPX kind of model, whatever the model organization is using. But to understand the model and troubleshoot the model and maintain the model, so OSI models are very useful. Okay. So irrespective of what operating system, what network model it is, what type of topology it is, this is very useful. It contains 7 layers, guys, 7 layers. That's why it is called a 7-layer model. This model is standardized by ISO, International Organization for Standardization. OSI model is having 7 layers: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and a physical layer. So transport is a heart of OSI model, end-to-end connectivity. End-to-end, it provides end-to-end connectivity. Okay, this top 3 layers, application layer, presentation layer, session layer, is called as a top layer or a upper layers or software layers it is. Bottom 3 layers, physical layer, data link layer, and network layer, these are hardware layers and bottom layers it is. Okay. So we are already seen that is when we are learning about hub switches routers. Hub is example for a layer 1. So this is the layer 1 physical layer. Switch layer 2, data link layer, router layer 3, network layer. So these are the hardware devices. That's why this is networking layer. So we learn one by one layer, guys. Yesterday I didn't explain layer by layer information. So today we'll discuss first. And yesterday we discussed about a protocol. So we spend more time on this protocol part only. What is a protocol? It's a set of rules. By the protocol, it defines what type of communication. Okay, what is your server to client, client to server. So to understand what type of communication it is, protocols are useful. Like a HTTP, FTP, SMTP, POP3, or IMAP, or NTP, LDAP. So different type of protocols which defines different purpose of communication. HTTP, HTTPS, web type related communications. Guys, every protocol has a certain port number. These are some protocols and their port numbers are given used in a regularly. We use these things regularly in the network. Protocols and the port numbers. The port numbers are certain port numbers are reserved port numbers for a particular protocols. Okay, so that is the thing. So I already told what is the difference between HTTP and HTTPS, and yesterday also I given few links. That is not yours. Where is this? This is yours. What is your why this is not showing any history? Yesterday only I sent the links. Application Paula maybe. These are the one previous batch questions, guys. Just read the questions, and this is a topic-wise questions. I divided based on the topic-wise regular questions are given. Okay. So these are yesterday class videos. See here it is. I given these are a small 5 minutes maximum videos. At least you will get a pictorial idea to understand what it is. Okay, that's why I said not only this, in this channel, so there is so many videos also there. Okay, you can refer it also, but you have to note down what he's saying. You have to note down the key points and read it and practice how to tell an answer. Okay, so these are the protocols we discussed yesterday: HTTP, HTTPS, FTP, SSH, Telnet, RDP, SMTP, POP3, IMAP version 4, TFTP, DHCP, DNS, NTP, Kerberos, LDAP, SNMP. Like these are the protocols we discussed in yesterday class. Okay. So today we are going to discuss from one by one of OSI layer. But why I told the protocols and port numbers? Because of in OSI layers, in network communication, okay, these protocols are very important. As per the first layer, application layer, protocols are very important. Today is 31/03/2023. Okay. Client and server application. Okay, first layer is, what is the first layer, guys? Application layer. First layer is application layer. So what is this application is layer is dealing with? What is application layer is dealing with it? Guys, I want to open a web page. Where can I open a web page?
On the web browser using
Very
internet.
good.
Browser.
Very good. I want to open a website in the web browser only, right? In that web browser, I am using a protocol called HTTPS. I want to transfer a file, I want to upload or download a file, then I have to use FTP protocol. But where we should use FTP protocol? In that particular type of application only. Okay. So one of the example is FileZilla. Okay. Here I have to put my remote server IP address, name, username and password and port number and get connected, and I can upload and download a file from remote machine, a remote server. Okay. So this is FTP related client side application. Web browser, client side, okay, web client application. Web client application. Okay. So I want to send a mails. I can use Outlook application to send and receive mail. I'm using an Outlook application to send and receive mails from client side. I'm talking. Okay. So I want to connect my remote server using a Putty application. Yesterday I tried to show that one, but it is not happen because my server is not cooperating with me. So guys, this is a Putty application. If I have my remote server, I want to connect with SSH protocol. So here I given the remote server IP address, for example, just like this. I given my remote server IP address and protocol is SSH port number 22 open. Or this server is we should access through Telnet, for example. Server is not SSH type, it is Telnet type. So then I will select Telnet, IP address, protocol, port number, and open. Okay, so this is a client-side application to get connecting my remote server. Okay, yeah, even this is my WhatsApp application. This is Microsoft Teams application. These are all we are connecting remote server, and so then we can able to send and receive information. Okay. Okay, so that is comes under this application layer. So these protocols and their client side and server side applications comes under application layer, just for a basic understanding. Okay, client side application, server side application. Web browser is a web client application, client side application. Web server is there. Web server use some web server related application like tomcat, ngix, apache http, microsoft iis. So these are things used by server. Outlook is a mail client application. There is a mail server, so that is exchange mail. Microsoft application, exchange application is there for mail server application. Zimbra application, mail application it is. Putty application use it to access remote machines, remote access. Okay, access, remote access. SSH server and Telnet. FTP Filezilla, cuteFTP, FTP server. That is RDP, mstsc is an application to connect remote machine through RDP protocol. Okay, guys. So this is different client applications, server side applications are there to communicate in the network, and we use different protocols to communicate in the network. So these things will comes under application layer. Application layer is dealing with these things. Next one is presentation layer. You guys understand application layer?
HTTPD.
HTTPD, Apache HTTPD is a small package, and it is a one kind of service also. So this is a Apache HTTP server, web server package. Okay. It is designed to run standalone daemon process. It is a daemon process.
Okay, sir. Okay.
Okay. Very good. Very good. That's the thing is important.
What about, sir?
Yeah.
What is the main exact difference in the Gmail application and Outlook, sir? Why, in general, I
Ah,
am asking, sir.
no, no problem.
Every
No.
people use Outlook for the.
Mail communication we can access. Yeah, very good. That is. We can access mails through web browser. Okay. And in earlier days, from very earlier days to till now. So what is this? Okay. Earlier days to till now, also we are using for a mail access purpose this Outlook kind of stuff. Outlook is a Microsoft related application, mail client application. As you ask, Gmail application, Gmail app. Okay. So Gmail app is also an application to access mails through an application. Okay, Gmail app. Okay. Right. So this from Google. That's a simple difference. But of course, working difference is also there. In generally, in your mobile, you are having a Gmail app that is um, IMAP type Gmail app. It is okay. Don't go to that much. Okay. Is- Outlook is a traditional desktop. No. Outlook is a traditional mail client application from Microsoft. Gmail app is from Google. Okay. So next one is presentation layer, guys. I will tell. Just give me 1 minute. Okay, guys. So we'll continue. So next one is presentation layer. In a presentation layer, data can be in any format. See, it is a picture format, JPG, PNG format is there. Okay, data can be any format. GF, for June, present already.
Sir, Monu Kumar present, sir.
Already given attendance, just now only I given. Just now only I given. Okay. Next, data can be any format, video format, MP4, 3 format, MP4 format, WMV format. Okay. So data can be any format, PDF format. So data we are accessing HTML formats, CSS, or what we in JavaScript format, ASP, uh, um, JSP. Okay, so any kind of format, and it is okay. The data should be converted, right? Whatever the format of data, it should be converted into ASCII format. American Standard Code for Information Interchange. Okay. information interchange, and it will be converted into again binary. Okay, it will convert into binary format. Okay, so here whatever the data format it is, it will be converted into ASCII to binary. Machine understandable language it is. And the data will be compressed. While you are sending a data will be compressed. Encoding, decoding, compression and decompression of a data, encrypting and de-encrypting. Already I told HTTP data is no encryption. HTTPS data is encrypting. So you are using HTTPS means at presentation layer data is encrypting. Telnet, no encryption. SSH, encrypted. Okay. So data is encrypted at a presentation layer only. When you are sending, it is encrypt and send. When you receive, it is decrypt and receive. Okay. Session layer. Guys, understand presentation and application layer?
Yes, sir.
Okay.
Yes, sir.
Guys, what is a session layer? So, when I have to send a request and I should get a information or a reply or a response from the server, from other, right? A send a request to B means A send it something and B has to give some reply. Okay, either server to client or client to server or one PC to another PC. It sends something, it will give something. Okay, so when you are transmitting a data, okay, so your data can be in a separate parts, right? So it is a command, it can be data, it can be protocol, it can be an IP address, so many things in your information. Okay, these are all combined here. Like you open a web page, see it has names, links, advertisements, pictures, icons, thumbnails, right? These are all there, right? These data is stored in different places. Okay, so while you are sending, while that server is sending, it combine all these things together as a single piece. Okay, and SNN ID. Okay, in a SNN ID, and it transfers with that ID only. Once client receives completely, then this will be gone. ID will be gone. Okay, so simply I am telling guys, session means, so I am want to send a request and to a server, I want to open this particular page, or I want to upload a file, or I want to access my mails. So when you are sending, we send with the session ID. So total transaction, send, receive, complete the total process should be done in the same session ID only. I'll give you best example. When you do transfer a money, right? You go to shop or like that only. You done any IRCTC reservation, or you book you went to this Amazon, Flipkart, you purchase something, right? Okay, you purchase
Yes,
something.
sir.
So what you do, so first of all, you open a Amazon website, for example. So you open Amazon website. you search for a port, you search for a particular product. Okay, you search for a particular product, you add to cart up to here, up to this, good. Then what we will do once it is cart is done, so when you are added all items into the cart, we'll go for a payment. But payment is not done by, payment is not processed by this Amazon, right? Payment means you have a bank account or credit card related or a debit card related sources. It is should be bank. In bank you have money, not in Amazon, right? Even Amazon bank also having separate. So what it will do, when you go for a payment, when you given your bank details, it will send to the bank. Bank verify your identity, okay, and it will send OTP to confirm and detect the money in the bank, money detected from bank, and transfer to Amazon. Amazon accepts that payment. Now payment is successful. Money transferred to Amazon, then payment is successful. Once payment is successful, then it will display payment successful. So proceed at the next thing. Order is confirms, order confirm, order is placed or order is confirmed, right? This entire thing will be done in the same session only. Okay, so you may experience this one. Do not refresh or press the back button. Okay, so when you go to anything, so it will say do not refresh or press the back button. Confirm resubmissions, this kind of stuff. If you are refresh anything, okay, generally do not refresh or press the back button. Okay, it is showing all old kind of pictures only, not a new picture. Okay, please wait, redirecting to payment acknowledgement page. Do not press back or a refresh button. Okay, so here it is also showing that one. Please wait while we process for a transaction. Do not press refresh or go back button will occur a multiple transaction on your credit card. Okay, meaning is if you refresh in between while this process is going on, if you refresh your page or you go to back button, you don't know what happened. Is a payment can be detected or payment can be failed. Fail is okay. It is detected but not given to Amazon. It is detected and given to Amazon but not connected to your process, your original product. Amazon taken a money and you don't know where it is put because the backend session is gone. If you refresh or you press the back button, the session will be expired. New session will be created. That confuses entire process. So that's why it is do not refresh the button. Okay, but in generally for session layer guys, only one line sentence only people will give, but session layer is a very important in the network transactions. You know, when you are transferring money or you are doing some payment kind of stuff, in that one it is very, very important. You know, even myself, I'm trying to book my ticket, so I connected to Wi-Fi router and I'm booking the ticket in my mobile phone. Suddenly power cut. So session is expired. Session is terminated. Session is terminated, but my mobile is immediately connected to 4G. Okay, my mobile is immediately connected to 4G. Even though it is not continuous, I have to log out from my ASCII application. Again, I have to log in because the previous one with one session, that session is terminated. Then I have to log in again. Okay. So one more is there, guys. Last one. This is my Gmail account. So I'm not touching anything. I don't do any refresh. When a sender request, I got that information. But any new mails are came, any new updates are came, it display on my screen, right? Any new mail came, immediately it will be here only. Okay. So as per my session, so once session is done, the session is expires automatically. But how can I get a new things again and again? Because the browser will create this, refresh the new sessions. Okay, it will refresh our page. Even we don't know whether it is refreshing or not. We look like a normal it is working. Okay, so automatically it will refresh the pages. That's why some people will suggest do not keep your caches, histories, clean up all the things at least once in a while. Why? Because of your browser will keep refreshing the internal content data, so that will consume the backend data, backend. I can say the backend these cookies and all. So it will consume. Mind is not connecting. Okay, yeah. Guys, understand somewhat about session layer, where it is very important of session layer at least.
Yes, sir.
Transport layer. Transport layer is provide end-to-end connectivity, because entire transaction, entire data is actually taken care by your transport layer. It is a middle layer, means almost first 1, 2, 3 are software layers, but transport is not a software, not a hardware. Okay, it is a middle layer of your OSI model. What transport layer will do? Transport layer segment the data, means you have a data. For example, I have a message I'm sending like this: hello, how are you? I'm divide the data. What transport layer is doing, it segment the data, means cut the data into small pieces. After that one, it will put a number on it. Example I'm writing here, guys, just for our understanding. Okay. Example I'm writing like this. Okay. Okay. So here it is. I have a data. I cut the data into small pieces called segmenting, and I put a numbering on it. Okay, numbering and sequence. This is a numbering and sequence order. I put a number on each segment and it is in the sequence manner. Okay, what is the use of this? What is the use of this? See it is, guys. A send a data to B. A send a packet one by segmenting, means small size, it is easy to transport instead of sending a entire data. Okay, so I send a first packet. First packet is received and it will tell you acknowledgement for a first packet. Means hello is received. I send second packet. Second packet is also received. So it send an acknowledgement. It means how is also received. I send third packet. Third packet is not received. So it does not send any acknowledgement for a third packet. No acknowledgement. Means R is missing. Okay, mean R is missing. I send fourth packet. Fourth packet is received. And it send an acknowledgement for a fourth packet. Means U is received. Okay. Now my A PC will check it. For first packet, did I receive acknowledgement? Did I receive acknowledgement? Did I receive an acknowledgement? No. So what it will do, it will send this packet again. Now this is received and it will send an acknowledgement. This now successfully R is delivered. Again it is acknowledgement is received, yes. Acknowledgement is received, yes. So now all packets are done. So they have to assemble it like this, no? So they will assemble a hello, how you are. Wrong, right? So what it will do, based on this numbering and sequencing, so that will be arranged again to normal order. Okay. Okay, this is the also called as a error correction, error detection and error correction. It correct the error. How it will correct the error, guys? It will resend the missing or corrupted packets. Okay, it will resend the packet again. Which packet is missing or which packet is corrupted at that other side. So it will verify based on acknowledgement, it will resend the packet. Okay. So your transport layer provide end-to-end connectivity. It segments the data, means it chop the data into small pieces. Okay. Numbering and sequencing, it means it will put each piece of data, they put a number in the sequence order. Because of this order, it can able to do error correction. This is what I explained. Guys, understand up to here?
Yes, sir.
Multiplexing, demultiplexing of protocols into TCP and UDP. TCP and UDP. Okay, what is this? People will read TCP, UDP and they will tell the differences, but what is exactly this TCP, UDP differences? Guys, we discussed the protocols. You know, a lot of people, if they told me, sir, in my college, people don't tell protocols, port numbers. You are telling very wrong way. Okay? No, guys. It is very important. That's why I told earlier. Each protocol is meant for a certain type of communication, right? Certain type of communication. And these protocols are either TCP type or a UDP type or both. A protocol can be a TCP type protocol or it can be a UDP type protocol. TCP type protocol having one kind of behavior UDP type protocols having another kind of behavior. Okay. For example, you take HTTP. HTTP is a TCP type protocol. TFTP, not FTP. TFTP is a trivial file transfer protocol, is a UDP type protocol. Okay, guys. DNS. DNS is both TCP as well as UDP type protocol. Okay. So like that, protocols could be TCP type or UDP type. TCP type protocol behavior is like this. It is acknowledgement based protocol. Acknowledgement based protocol. If I send a packet, source send a packet, destination received a packet, source send a packet, destination received a packet, and destination will send an acknowledgement for that packet. In TCP type of communication is like this. Source send a packet, destination received it, then it will send an acknowledgement. So once source received an acknowledgement, it understands destination is received a packet. Destination is received a packet. Same thing. Source send a packet, destination received a packet, so destination send an acknowledgement to the source. Source understand, whenever source received a packet, acknowledgement, so source understand destination is received a packet. Source and a packet, destination is not received a packet, or maybe it dropped the packet or something is happened. It does not send any acknowledgement. Means when source does not receive an acknowledgement, means destination not received a packet. Source not received acknowledgement of that particular packet, it means so destination not received a packet. So what it will do, it will send the packet again. It will send the packet again. Once destination received a packet, it will send an acknowledgement. Okay, and source received a packet. Acknowledgement packet. So then source understand destination is received a packet. Okay guys, this is a acknowledgement based communication. In this one, source knows destination is received a packet or not. Destination is received a packet or not. Destination is received a packet or not. Guys, understand TCP?
Yes, sir.
Very good. Now here it is, source send a packet, destination received a packet. Source send a packet. Source send a packet. Source send a packet. Destination received or not, source don't know. It will keep sending packets. So don't know destination received a packet. That is a UDP type protocol's behavior. So it will send and it don't know whether destination received a packet or not. So that is UDP. No acknowledgement. Here we don't use any kind of acknowledgement. Source don't know whether destination received a packet or not. Okay. So we have a protocols. The protocols are either TCP type or UDP type. Transmission control protocol, user datagram protocol. TCP is a acknowledgement based, UDP no acknowledgement. Okay. Source send a packet to destination, destination give acknowledgement to the source. When source received an acknowledgement, so source understand, destination received a packet. If source don't receive a acknowledgement, so source think destination not received a packet. Okay. So these are some example: HTTP, SMTP, FTP, SMNMP. These are an example for a TCP type protocols. DHCP, TFTP, THH or UDP type protocol, but DNS is both TCP and UDP. TCP type protocols, also called as reliable protocols and connection oriented. Guys, connection oriented does not mean wired or wireless. Guys, I am using a laptop. I connect my network through wirelessly, but I'm unable to communicate with HTTP, FTP, SMTP, right? SSH, Telnet. These are all TCP type protocol, but I'm using wireless communication, right? So, in some colleges, some lecturer will tell, so connection oriented means wired, connectionless means wireless. It is wrong concept, guys. Connection oriented means source knows destination can able to destination is received a packet. That is a connection oriented. Connectionless, it does not mind about a destination. It will send a packet to destination, whether it is received or not. Source don't know. Okay. Reliable and non-reliable protocols. Reliability and connection oriented mainly because of source know destination is received a packet. Non-reliable are a connectionless because of source don't know destination received a packet or not. Oh, guys, understand this oh, no, transport layer not finished. We are in this point, okay? Sorry. Small points are there, okay? Segmenting, numbering, and sequencing, multiplexing and demultiplexing of TCP, UDP protocols, guys. What this packet construction is in this OSI model, how it is happens in transport layer. There is a TCP and UDP boxes are there. It is TCP box. This is UDP box. While you are communicating, you may use different protocols. So you are using TCP protocol, then it comes under, they will put it in TCP box. UDP protocol you are using, then it will put it in a UDP protocol. Okay. So it will multiplex all your TCP type protocol into TCP box, all your UDP protocols into UDP box. Okay. You guys understand up to here?
Yes.
Yes, sir.
And our transport layer also do flow control or a windowing. What is this flow control or windowing? So I am sending a packets to the destination, right? I'm send a packet from source to destination. Continuously I will send like five packets at a time, 10 packets at a time I can able to send. But destination may not be received it. Our destination don't know how many packets at a time source is sending. Okay. So what it will do, source will tell I am sending 5 packets. So destination, okay, 5 packets are collected or anything is missing, which one is missing? Okay. So destination can understand, yes, source is saying I'm sending 5 packets. When you go to shop or when you go to someone is sending some items to you, then says it, I'm sending 5 items. please collect and check it. 5 items are there. Big basket. So so when we order 20 items, he will count 20 items. Totally 20 items are there on that the list. Okay. So similarly, so windowing and flow control, it is always a difference in a communication, right? So I can send 100 packets at a time, but this cannot able to receive 100 packets. It can able to receive 10 packets at a time. Okay. So there is an estimation. So it will send first 10 packets because it can able to receive up to 10. So then as it is, I'm sending 10 only. Then it will receive and it will collect all the 10 packets first. Then it will give acknowledgement for all 10. Okay. So that's a windowing, guys. Simply say how many packets at a time we are sending, that will be added in transport layer. So destination can understand how many packets it has to receive at a time. And also it is estimates the source and receiving source estimates the destination receiving packet capacity at a time. How many packets it can be received at this time or at a time. PDU, packet data unit. Data is any layer called a PDU, guys. This is one more is there. I'm getting bored. We have a application layer, presentation layer, session layer, transport, network, data link, and physical layer, guys. We have a data in each layer, right? So we have data from each layer. Okay. So whatever the data in the layer, we call it as a PDU, packet data unit. Whatever the layer it is, we call that layer data is PDU, packet data unit. In first application layer, PDU is a data only. It's in data only. Second in one is also data. Third one is also data. Okay, whatever the data in the layer changed or created or added, okay, whether it is encrypted or compressed, okay. So whatsoever it is, the data is, we call it as a PDU. PDU. Every layer data is called a PDU only. But in first three layers, the PDU is data. PDU, the name is data. In transport layer, data is got segmented and added with numbering and sequencing. TCP, UDP, TCP, UDP multiplexing information, mean TCP, UDP protocol information is added. Window information is also added into the TCP header. So there is a TCP header plus your PDU from previous layers, session layer. Means application layer PDU sent to the presentation layer PDU sent to the session layer is PDU sent to the transport layer. Okay, for that layer, for that PDU, a TCP header is added. This TCP header contains about segment information, numbering and sequencing informations, TCP UDP protocol suite information, windowing information, number of packets I am sending, that information also added. The total data, we call it as a segment. This total data in the transport layer is a PDU. That PDU name is here segment. So this PDU name is segment. Okay. This segment is sent to the network layer. This segment is sent to the network layer. Guys, understand up to transport layer? Only 3 more layers are there. Understand what is PDU? What is segment?
Yes, sir.
Yes, sir.
Yes.
Very good. So this segment send to the network layer. In network layer, two parts: routing protocols, routed protocols. Routed protocols means logical address, IP address, IPv4, IPv6. What I'm saying, routed protocols means logical addressing. When you are communicating, compulsory required logical address means IP address. Routing protocols means you are communicating from one device to another device. You must know the path, how to reach the destination. That will be told by routing protocols, RIP, ASCII, OSPF kind of stuff. Okay. This network layer is dealing with a routed means IP addresses, logical addressing or IP addresses, and also it is dealing with the routing protocols information also added, like a RIP, ASCII, or routing information is added here. So we got a segment from transport layer. We got a segment from transport layer, and network header is added to this segment. What is the network header contains about a source IP address, destination IP address, and routing information. Then totally it is become a packet. So network layer, from network layer, the PDU is packet. The PDU is called a packet. Okay. So what happened? This segment sent to network layer. In a network layer, it is added with the source IP address, destination IP address. Okay. Okay. Guys, understand network layer?
Yes, sir.
Yes, sir.
Yes, sir.
Data link layer. Data link layer. Data link layer having two sub layers, guys. Like there in a network layer, we have routed and routing protocols. Same way, it is two sub layers. One is LLC, logical link control. Logical link control. Logical link control. Okay. What is this LLC contains? LLC with the WAN protocols. WAN protocol. You are connecting through WAN. You are inside a network, that is LAN communication. You want to communicate it to WAN. You have to communicate through WAN protocols only. Okay. To communicate in a LAN, normal protocols. But when you are communicating through WAN, you want to connect it to WAN. It means you need a WAN protocols. PPP, SDLC. Of course, SDLC no one use. It's in between Cisco routers to Cisco routers only. Now it is become a open protocol, but still SDLC is very less. Main protocols are PPP, frame relay, MPLS. Now most of the companies are using MPLS WAN protocols, guys. So multiple protocol uh, uh, leads circuit something is there. So 1 second, sorry. PPP point to point protocol, MPLS. Okay, multiple protocol label switching is a networking technology that route traffic using shortest path based on labels rather than a network address to handle forwarding over the private wide area networks. Okay, advantage of this MPLS, guys, different type of protocols like voice over IP. Anybody knows VoIP, VoLTE? What is VoLTE?
Mobile network, sir.
Very good. What is
Network.
LTE? 4G is a very long time waiting, means very long time 4G is useful. Very long time we can use this 4G. Okay. So LTE means it's 4G LTE. Okay. So voice over this 4G means you can communicate through mobile data, mobile data communication. Okay. We are communicating different way earlier. Now also we are communicating old style 2G type of communication, only, basic communication only, for voice. In Jio and Airtel launches this voice or LTE, so then through mobile communication, mobile data communication also, with the 4G voice communication also, you can HD quality voice you can get. Same concept. Voice or IP means, US calling, people are there now, so US calling, so you have to communicate through your US office, US client, you have to communicate. How to communicate? So telephone bill, normal telephone bill, it is huge. So what they will do? They will connect from there to India through WAN connectivity. Here one voice or IP server, here voice or IP switching server is there. Okay, and these telephones connected through LAN cable only. These telephones are connected through LAN cable only. LAN cable to this server from here to here. So through internet you are communicating, voice communication through internet. Okay, that is a voice or IP. Okay, so like this, different protocols also we can easily switch from like WAN through communicate through WAN. Okay, so that is MPLS technology. Guys, this is a data link layer. Data link layer having two sublayers. One is LLC, logical link control. Okay, logical link control dealing with the WAN protocols called PPP, SDLC, frame relay, MPLS kind of stuff. PPP has, these are all WAN technologies, WAN connectivity technologies. Okay. MAC layer. What is a MAC layer? Media access control. What is the media access control MAC layer? It is a 48-bit represented in 12 hexadecimal, and it is also called as a physical address. Every NIC has a MAC address. Either it is a virtual NIC or physical NIC or cable connecting NIC, or maybe it can be a Wi-Fi related NIC. So every NIC having a MAC address. It is also called as physical address given by manufacturer of that NIC only. In MAC layer, guys, from here in data link layer, we got a packet from trans network layer. We got a packet from PDU, packet from network layer. To this packet, there is a data header, a data tail is added. This network source MAC address, destination MAC address is added to packet, and CRC, cyclic redundancy check. Cyclic redundancy check. Okay, what is this? We know the source MAC address means A's MAC address, and destination B's MAC address added to your packet. What is this CRC? What is the cyclic redundancy check? Guys, it is a kind of algorithm to check for a data correct errors. Is my data is safe or data is corrupted? Check by this CRC only. So the CRC is adding here, and source MAC address, destination MAC address added to your packet. Then your PDU become frame. Frames and to a physical layer. Okay, so then it become a frame. So guys, remember, error checking happens at data link layer. Error corrections happens at transport layer. Okay, error correction happens at transport layer. Error checking by CRC happens at a data link layer. Layer 1. Layer 1, physical layer. Layer 1 is a physical layer. This physical layer is converted into bit stream. Sorry, at physical layer. So at physical layer, the frame is converted into bit stream. Okay, so the frame from the data link layer is converted into bit stream. The bit stream again converts into electrical signal, or it can be converted into radio signal, or it can be converted into light wave signal. Depends upon what kind of media you are using. Ethernet, or you are using Wi-Fi type of connectivity, or fiber optical connectivity. For example, you are using desktop or laptop with Ethernet, UTP, STP cables you are using. So that is electrical signal. The Wi-Fi signal is, if you are using laptop or mobile, we are connecting through Wi-Fi, then it is a radio type of signals. Fiber channels, if you are connecting through fiber channels, host bus adapters like HBA controllers are there. Fiber cables, we need a light wave signal. It converts into light wave signal. So physical layer is like that. Okay. So guys, this is the totally your layers.
What is the UTP and STP, sir?
Yesterday you are there or not?
Yes.
Hmm?
Yes, I was there, sir.
And then I said about cables. When I said cables,
Yeah.
I think last class only. So not on 20, 30th. Yesterday, I think, or maybe day before yesterday. Okay. So we have a cables. Have you seen this type of cables?
Yes, sir. Yes.
Yeah, our network cables are there now. So that is okay. So That cables are either it is a UTP or a STP cables. So we have a connectivity. This is called a RJ45 plugs or RJ45 connectors. The cables we are using in our regular LAN network is called a this type of cables we are a UTP or STP cables. STP cables additionally they have a shielding inside only. Okay, they're having a separate shielding like this is there. In UTP shielding is not there. Okay.
Okay, sir. Yeah, I remembered.
Very good, very good. So not only you only guys, everyone must read every day. Just everything is in one place only, right? So what is the point? You can access from your mobile phone with a simple link. You don't require a laptop or anything. Even from a mobile phone, you can access this link. If you miss the link, I can share the link again, no problem. Okay. Very good, very good. That is a good thing you asked question. So guys, last point I want to tell that is, yeah. Once again, guys, I am sending a packet from PCA to TCP. I'm sending packet from PCA to TCP, A to B. This is source and this is destination. Source and destination. Okay. So first one is application layer. So you open a browser, you put some URL, or maybe you are sending some request. Right? So you the protocol and web browser you are using. So application layer. And this is the destination. You are sending a message through some message application. Okay. Next, presentation. Please, what are the data here in the presentation layer? Like you are sending a file, or maybe you are uploading a data, or you are sending a mail, you are giving application through HTML format. Data is converted into ASCII format, means encoding data. It encode the data. It compress the data. And it compress the data. Next, okay, encode the data, compress the data. Okay, and what is another one? Encrypt the data. Encrypt the data. Application layer, presentation layer. Next one is session layer. Session will be created and maintained and terminated. So new session is created. So all this data kept in this session and given to the transport layer. It segment the data, numbering and sequencing, and windowing, TCP UDP multiplexing. Network layer. It adds source IP, destination IP. Data link layer, source MAC address and destination MAC address. Last one is physical layer. It converts frame into bit stream. Bit stream into, for example, electrical signal. I am using wires. And physical layer receive this electrical signal, convert into bit stream to frame. The frame sent to the data link layer. In a frame, data link layer verifies source MAC address, means A's MAC address, B's MAC address, and CRC. Check the data with CRC. Data is having any errors or no errors. If data is corrupted, it drop the packet. Data is good, it accept the packet. Source MAC address and destination means A's MAC address and B's MAC address is there. No? What it will do, it kept aside A's MAC address. It kept aside A's MAC address. A's and this packet, A's MAC address. So destination learn the MAC address like that. A's MAC address. Next, what is the content this? This is a packet. This packet go to network layer. Network layer in packet, source IP address means A IP address and B's IP address. It verifies A's IP and B IP. Both are same or not. B's device IP address and this IP address is same or not. B machine's MAC address and this MAC address is same or not. Both are same, then accept the packet. Not same, drop the packet. Okay. So IP address same, accept the packet. Like that. So first MAC address same, accept the packet. IP address same, then accept the packet. Like that it will happen, guys. It verifies source IP address, destination IP address, destination is matches, accept the packet. And it kept aside source IP like this. Okay, so when it is sending back, so then it is useful. It's so destination learn the MAC address of source machine and source IP address of source machine maps and kept in a table called ARP table. ARP table. Next, what is the remaining part is segment. This segment sent to the transport layer. It assemble all the segments together at transport layer. That's why end-to-end connectivity means whatever the data is divided here, okay, that will be assembled into one single unit. It's using segmenting and numbering sequence, and as per the protocols, everything will be assembled here only. Okay, so this is your data now. And if any packet is missing, so automatically it receive that remaining packet and it reassembled pack, and we got a data here. Error correction will occur here. Session layer will be verified what session, what kind of information. Okay, session ID. Okay, again presentation layer. Data is encoded data, it decode the data, decrypt the data, decompress the data. Then application layer means if it is their side application, maybe it is a server application or maybe it is the normal application. So it is that application layer understand what protocol, what kind of request it is, okay, and what kind of reply we should give it. Okay, that is understand by application part of data link part. Okay, guys, as I said, when you are sending a message, application to physical layer, when you are receiving, physical to application. If I am sending now from B to A like this. Okay, so just to understand each layer and their packets, if you understand each and every layer, guys, troubleshooting is dead easy. Okay. Yeah, here is a comparison is there. I will explain separately this ARP, guys. Just now I told, but I don't know. Yes, TCP model, so which we are using regular network is a TCP IP protocol suite only we are using. So when you are comparing OSI with TCP IP, okay, so you can take application layer in TCP IP, application layer, transport layer, internet layer, and network access layer. TCP/IP protocol suite having only 4 layers. OSI model having 7 layers. Okay. Of course, OSI model is reference model. It is. Application layer in a TCP/IP will do 3 layers job. Application, presentation, session layer jobs done by one application layer only. Okay. All these three combinedly, one layer will do that job. TCP/IP protocols transport layer. Okay. So transport layer is same as a OSI model transport layer duty only. Internet layer in the TCP/IP, it is network layer in a OSI model. Network access layer is a combination of physical and data link layer. Okay. So application presentation session is application in TCP. Transport is transport. Network is internet. Data link and physical is network access layer. Guys, we have a NIC. Our LAN cards are there now. That is comes under network access layer. Huh? Yeah, comes under network access layer of a TCP IP because of our NIC is a physical device, physical connectivity, plus it understand MAC address. Okay, so that's it is network access layer. So this is a OSI and TCP IP comparison. Okay, there is some few points are there, but that is enough for it now for this class. Okay, guys, understand?
Yes, sir.
Very good. Okay, so take a break, guys. Come back, and then we'll start with the IP address part.